Next, we are going to see path vector routing. So path vector routing is an interdomain routing. So in path vector routing, there is one node in each autonomous system that acts on behalf of the entire autonomous system. So in path vector routing, there is only one node in each autonomous system that will act on behalf of the entire autonomous system. That one node is called as the speaker node. The speaker node in an autonomous system create a routing table and advertise it to the speaker nodes in the neighboring autonomous system. So in path vector routing, there will be one node in each autonomous system. It will be acting behalf of that entire autonomous system, and that particular node is called a speaker node. And the speaker node in an autonomous system creates a routing table and it will advertise it to the speaker nodes in the neighboring autonomous system. The idea is same as the distance vector routing, except that only the speaker node in each autonomous system can communicate with each other. Here the advertisement is also different. Here the speaker node advertise the path and not the metric of the nodes in the autonomous system or other autonomous systems. So initial routing tables in the path vector routing. So here this is one autonomous system, this is on autonomous system, this is on autonomous system, and this is on autonomous system. In this autonomous system AS1, A1 is a speaker node, and in the autonomous system 3, C1 is a speaker node, and in autonomous system 2, B1 is a speaker node, and in autonomous system 4, D1 is a speaker node. So in this autonomous system, the routing table is nothing but A1, it is present in the autonomous system 1, A2, autonomous system 1, A3, autonomous system 1, A4, autonomous system 1, A5, autonomous system 1. So here the routing table for the autonomous system 3, C1, C2, C3, all are present in the autonomous system 3. This is the initial routing table of the path vector routing. So initialization. At the beginning, each speaker node can only know the reachability of the nodes inside its autonomous system. So in the previous figure, we have seen all these things. Now, stabilized stable for 3 autonomous system. Okay. So this is a stabilized stable of autonomous system 1. So A1 is in autonomous A1 to A5, it is in autonomous system 1. B1, autonomous system 1 to autonomous system 2. Then C1 is C1 to C3, autonomous system A. This is a table of A1, autonomous system 1 to 3. So similarly for D1 to D4, autonomous system 1 to 4. So this is a the C1, it can be reached from autonomous system 1 to autonomous system 3. Similarly, B, it can be reached from autonomous system 1, autonomous system 2. Similarly, D, it can be reached from autonomous system 1, autonomous system 3, autonomous system 4. So this is a routing table. So this is the routing table for the first one. So we have seen the table. Okay. So this is a stabilized table for 3 autonomous systems. So next is sharing. In path vector routing, a speaker in an autonomous system share its table with the immediate neighbors. So node A1 shares its table with the B1 and C1. Node C1 shared its table with the D1, B1, A1. Node B1 shares its table with the C1 and A1. Node D1 shares its table with the C1. So these are the neighboring autonomous system. This A1, it will share its table to C1 and B1. C1 will share its table to B1 and D1. And D1 will share its table to C1. And A1 will share its table to C1 and B1. So next one is updating. When a speaker node receives a 2-column table from a neighbor, it updates its own table by adding the nodes that are not in its routing table and adding its own autonomous system and the autonomous system that sent the table. After a while, a speaker has a table and knows how to reach each node in other autonomous system. So loop prevention, the instability of the distant vector routing and the creation of loop can be avoided in path vector routing. When a router receives a message, it checks to see if an autonomous system is in the path list to its destination. If it is, then looping is involved and the message is ignored. Policy routing. Policy routing can be easily implemented to path vector routing. When a router receives a message, it can check the path. So if one of the autonomous system listed in the path is against its policy, it can ignore that path and that destination. It does not update its routing table with this path, and it does not send this message to its neighbors. So optimum path. So optimum path depends upon the autonomous system. Okay.